Hey, what's going on, guys? Vega here from Serpent X Special Forces, and in this video I want to talk to you about the RTX 3080, specifically the Gigabyte Eagle. This card is great for gaming, however when it comes to memory intensive applications like crypto mining, maybe not so much. This card during gaming I'm able to easily hit 20-40 megahertz on the core, and the memory overclocks well just like most of the 3000 series, obviously within reason. We're not pushing, you know, plus 1200, plus 1300 on the mem. A couple of design issues that I have with this card. The notch, I know it's there for NVLink on the 3090, but you know, with the 3080 and the lesser cards, they don't have NVLink, so they could have removed the notch, but I understand it may be cheaper to mass manufacture these coolers rather than having to design each one for each of the various models. Specifically, a lot of people have been telling me they're unable to get past the 200 watt point when trying to mine crypto, which I did not experience with the Founders Edition. However, I am experienced with this card. So without further ado, let's switch over and get into more details of what I'm seeing and why we're seeing it. Alright guys, so we're going to bring up some information here on screen. I just want to show you this. Specifically, let's go to this one first. On screen, as you can see, we got Unigine Heaven in the background, and our GPU is running at P state 0. Okay? Look at our core clocks. Look at our mem clocks. Everything is stock, right? Everything is stock, core clocks and mem. Even the voltage. Our temperatures are even getting warmer. The core temperatures are getting hotter. One key thing, though, is that we can't see the memory temperatures. We can only see the GPU die temperatures. On top of that, look at the fan speeds. Take note of the fan speeds only hitting 1500 RPM. Moving on to when we're mining. This is at the very beginning stages of when we're mining. You could see that we're getting upwards in the 90s and everything, just like we're supposed to with an RTX 3080. Look at the clock though. Now yes, I do have minus 400 on it, and I have plus 800 on the mem and minus 400 on the core. TDP, or power limit, set of 80%. However, shortly thereafter it will drop. The core clock and the P state will drop. Now take note of the fan speed. We're hitting 2500 RPM. It's doing that automatically. Everything is on auto. So it's doing that automatically and increasing the fan speed, even though the core temperature is only at 54 degrees Celsius. Moving on, it drops. So after X amount of time, you will see that it drops. No matter what I do, whether I change the memory clock, whether I increase the core clock or decrease it, everything drops. And look at the power limit. Even though I have it set at 80, it's dropping down to 65. Again, the fans are on auto, but it's stuck at 2500 RPM. So that got me thinking, why are the fans getting stuck at 2500 RPM? During gaming, it stays at P state 0. During mining, it drops to P state 2 because it's trying to save itself. And you can see in MSI Afterburner, the fan speed is up to 100% when it's on auto. So the GPU knows something we don't. And what that is, let me go ahead and bring up another compute. So P state 2, fan speed high, core clock dropping below 900 megahertz or thereabouts, even at stock clocks, other than the memory being increased. It's dropping itself. It's trying to save itself. What is it trying to save itself for? Well, if you look at the mega hash and you see everything here, the core clock, look at the bottom of this right here. Actually, let's just bring it up on my screen. So right below me, you're going to look for this section right here. This is the power limit thermal. And you can see that it says yes. Even in the screenshot, yes. Okay, there's also another one that is reliability. Hang on. Power limit, reliability, voltage. What's happening isn't related to the core, it's related to the memory. The biggest downside of this GPU from Gigabyte is the fact that the manufacturer did not include a number of things that could benefit the memory, like thermal pads on the back of the PCB, because we know GDDR6 and 6X is flip chip design. Therefore, we should have something kind of trying to take the heat away from the back of the PCB, where the memory modules is outputting most of its heat, and away from it. Now the backplate is aluminum or some type of light metal, so it can sink. I know it can only sink so much heat, but it can sink the heat, and with a fan, especially in a computer case, which it is, with the Noctua fans blowing air, any air, whether it's warm or not, over that back plate would help dissipate that heat. So the notch is one thing that annoyed me, but another thing is, why didn't Gigabyte include thermal pads on their card? We all seen this with the RX 5000 series. You know, there's a number of cards out there, especially the ASRock Challenger, which I had to show you how we can make the cooling mechanism a little bit better. And that's just simply adding thermal pads in the back of the PCB, connecting the PCB with the back plate, and then having some fans cool that back plate off. It still gets hot, but at least it's drawing the heat away from the PCB and the memory modules. More importantly, I just ran another test in mining before I started this video, and you can see we hit it again. The thermal limit, yes. We didn't hit the reliability voltage limit, but we did hit the thermal limit, and that is the cause of why the GPU is saving itself, why you're unable to push over 200 watts while mining, and while the core clocks are dropping down, and P state 2 is the state we get stuck in. I even forced it. There's a number of ways to force P state 0, but it's not going to do anything if the GPU memory is getting too hot. The junction temperature is 110C, but anytime you get past that, realistically, let's just say 95C, the GPU is going to try to save itself. It's going to try to drop clocks. It's going to do whatever it can. That's why the fans are ramping up so high when the GPU core was only so low, and we don't have a software way to see the memory temperatures as we do on the Radeon series GPUs. So software wise, I wish that Gigabyte or other manufacturers would include temperatures for memory modules, just like AMD did. However, that's not the case. Now, stay tuned, because I have thermal pads on the way. I got some Thermal Grizzly Cryonaut Extreme, which is the higher end, or it's 2 watts per meter Kelvin better at thermal dissipation or thermal conductivity than the normal Cryonaut. I'm going to have that as well as some thermal pads, and we're going to tear down this GPU and try to see if we can't make the memory just a little bit better than what it was. But do me a favor, hit the like button on the way out, guys. Subscribe for more content like this, and let me know if you're having this issue in the comments below. Let's chat about it and see if there's some way that we can fix your GPU. But we're going to try to see if better thermal pads, or just any thermal pads in the back of the PCB, will help contribute to us achieving the hash rate that we want without the GPU thermal throttling or hitting those thermal limits as I showed you in this video. Alright guys, I'm out of here. Take care. I'll catch you in the next one.